Hi, welcome to the video solution for mathematics. This is Edexcel IAL Mathematics C12 January 2017 part 3. So let's start. Question number 11. In this question, solution based entirely on graphical or numerical methods are not acceptable. We need to solve in the interval 0 to 2 pi the equation 3 cos square x plus 1 equal to 4 sine square, giving an answer in radian to 2 decimal places. So this is a trigonometric equation, and when we solve a trigonometric equation, we make sure that uh, we uh, we have we should have same trigonometric function. Like we have here two different functions, cos and sine, and it is difficult to solve in these form. So what do? We have two choice. We can convert sine square in term of cos square using a formula 1 minus cos square equal to sine square, or we can change cos square into sine square. That's what I'm doing. It's up to you, whatever you choose. So I am changing this cos square into sine square, and you know that 3 cos square, and cos square is 1 minus sine square x plus 1 equal to 4 sine square x. If you wish, you can convert sine square into cos square. So your equation would be 3 cos square x plus 1 equal to 4 times of 1 minus cos square x, and you can simplify this equation in terms of cos, and you can do the step that what I'm doing here for sine. It's up to you. So let's see, I'm solving in terms of sine. So if you simplify this equation, it will be 3 minus 3 sine square x plus 1 equal to 4 sine square x. Moreover, separate sign, so you have minus 3 goes over there, plus 7. That means 7 sine square x would be equal to 4, 1 and plus 3, 4. And then sine square x is equal to 4 upon 7. If you take the square root, so sine x is equal to plus minus 2 by root 7. So you have two values of sine. That means you can figure out the angle x at these values. So you can say that x is so you need to find the angle at which the sine is 2 by root 7. Here there is one important point that you need to keep in your mind, that the interval given in radian. So make sure that you convert your calculator mode from degree to radian. So once you convert into radian and calculate the x, so you will get 0.857, and we need to give answer in 2 decimal place, so you can round this off till 0.86. This is the angle for if you take x is equal to plus root 2 by root 7. And what if you take minus 2 by root 7? So your x would be equal to minus 0.857 or minus 0.86. So you have two angle for this function. And after this, once we have angle, the next step is we need to figure out the range of the angles. And how do we do that? We draw x-axis and the y-axis, and then 0.86. So because sine is positive, sine is positive, so I'm going to draw let's say this is two line because first and second quadrant sine remains positive, and this angle is 0.86. So this angle is also 0.86. Then how do we write the solution? So x is equal to, my first solution is starting with the positive x-axis till this first line. So first solution is 0.86, and the second solution is this much. That means, and this angle is pi minus 0.86, and pi minus 0.86 will give you 2.28. 2.28. So this is once you have positive angle. What about the negative value? In this case, you will draw the same diagram, but as sine is negative, so you say that this is your negative angle for sine. That means this is 0.86 and this is 0.86. And if you wish to find the angle between the 0 to 2 pi range, so your third solution would be starting with from here till there, so it will be pi plus 0.86. So your third solution would be pi plus 0.86. That means around 4.00 comma, and your next solution would be till here, so 2 pi minus 0.866, that means 5.43. So these are four solutions of your equation in the range of 0 to 2 pi. Next, solve for 0 to 360 degree, 5 sine 10 plus 10 degree equal to cos 10 plus 10 degree, giving your answer in degree to one decimal place. Okay, so 5 sine theta plus 10. So again we have two different trigonometric functions, sine and cos, but they are not in a square, they are linear, sine and cos. So the easy method to solve these types of situation is whenever you have a sine and the cosine with power 1, or the linear sine and cosine, you convert this in tangent, because you know that tangent theta is sine theta divided by cos theta. So thinking of this, I am dividing the whole equation with the cos theta plus 10. So I would have sine theta plus 10 divided by cos. That's why I can convert. So I can rewrite, just for your understanding, I'm writing this additional step. 5 sine theta plus 10 divided by cos theta plus 10 is equal to cos theta plus 10 divided by cos theta plus 10. Clearly this cos cancel will give you 1, and sine upon cos will give you tangent. So you have 5 tangent theta plus 10 is equal to 1. Now after this you have two choice. You can solve this equation directly, or you can convert this angle in a simple in term of a single variable x and change the interval, but I'm not going to do this because this is a quite simple or straightforward equation. So I'm going to find angle of tangent. So tangent theta, it is not minus, this is plus, tangent theta plus 10 is equal to 1 upon 5. And if you find tangent inverse, so theta plus 10 is equal to tangent inverse 1 upon 5, and it will give you theta plus 10 will give you 11.3. And when you find theta, so theta will give you 11.3 minus 10, that means 1.3 degree. So you can do the same step. Because tangent is positive, see, the tangent is positive, that means you must draw the line or angle of 1.3 in the first quadrant and in the third quadrant, and this is 1.3, this is also 1.3. Remember, these are just a sketch of these angles, these are not accurate scaled drawn, just to visualize the existence of the function. So it is not a scale angle, it doesn't mean that this is accurate at 1.3, it's just visualization that somewhere we have 1.3 degree and 1.3 degree. So my first solution, I have interval from 0 to 360 degree, so my first solution is this angle, which is theta is equal to 1.3 comma, and the next solution would be this much, that means 180 plus 1.3, so 181.3. and if I go for further calculation, then this angle would be more than 360, so I will not calculate the third rotation. So I have two answers, so 1.3 and 181.3 degree, the solution of this equation. Okay, question number 12. Figure 4 shows a sketch of part of the curve C with the equation y is equal to 3 by 4 x square minus 4 root x plus 7, and the point P lies on the C and has a coordinate 411. This is the curve, this one, with the equation y equal to 3 by 4 x square, and this is the point P. So the line is the tangent to the C at point P, that's the line L. Use calculus to show that L has equation is y equal to 5x minus 4. In other words, you need to find the equation of line L if it is tangent to the C. Remember, for equation of line, if you need to find equation of a line, generally you need gradient of that line and the point on the line. If you have these two things, then you can use slope point or gradient point form. Y minus y1 is equal to m times of x minus x1. So this is the general equation of a line if you have a gradient and if you have a point x1 and y1. You can substitute here to figure out the equation of that particular line. In this case, we need to find equation of the line, and we have a point somewhere. Let's see, this is the point P, 411. This point lies on the curve as well as lies on the line, because line is tangent to the curve. So this point P lies on both. So we don't need to worry about the point. We have a point. The only thing we need to worry is we don't have gradient of the line. That means we need to figure out how to find the gradient of the line. Generally, in calculus, when we differentiate a function or we find derivative dy by dx, this dy by dx is gradient of a tangent line. This is the gradient of tangent line. That's what you need to do. You need to differentiate the equation of the curve, and then you need to substitute the point on the gradient, and then you would have gradient of the line. So that's what you need to do. First you need to differentiate and then figure out the gradient, and then use slope point form to find the equation. So let's see. First you need to differentiate. So dy by dx is equal to, once you differentiate this, you have 3 by 4, and derivative of x square is 2x minus 4, and derivative of root x. So derivative of root x is 1 upon 2 root x. So 4 derivative of root x is 1 upon 2 root x, and derivative of 7 is 0. So you can see that dy by dx is 2 to cancel, it was not 2, it was 4. So 2, 4, 3 by 2 x, and then 2 by root x. This is the derivative, and at x equal to 4, you need to put x equal to 4 from the point to figure out the gradient of the line. So that means dy by dx, it will become m is equal to 3 by 2 into 4 minus 2 by root 4. So 2 times 3 6, minus root 4 is 2, 2 minus 2 upon 2 1, that means 5. So this is the gradient of your line. So finally your equation is y minus y1. These coordinates are x1 and y1. So y minus 11 is equal to 5 times of x minus 4. You simplify this, you have equation y is equal to 5x minus 9. This is your required equation. Next part, the finite region R, shown shaded in figure 4, is bounded by the curve C. The line x is equal to 1, the x-axis, and the line L. Find by using calculus the area of R, giving your answer to 2 decimal places. So that means you need to figure out this shaded area, this region. And the idea is I am going to figure out the area under the curve from the point P. The reason is, if they talk about region, area of the region using calculus, that means if you have a curve of any shape and you need to figure out area under the curve between 2 points on the curve, and these 2 points are basically shown by vertical lines like this, and these 2 points of the vertical line, these 2 are called limits, and this one is called lower limit, we use letter A, and this is called upper limit, UL, we use letter B. And if you integrate the equation of the function, or this function y equal to fx, if you integrate y between a and b, that means this thing will give you area under the curve above the x-axis. That means this whole region you can find using this approach. That's what I'm doing here. This vertical line is x is equal to 1, so this would be my lower limit, and this point, x coordinate of this point is 4. So if I integrate the function, the curve between 1 to 4 y dx, that means I would have the region, the whole region, shaded and unshaded, and I'm going to call this area as A1. And after this, I am going to figure out area of the triangle, that means the unshaded region, area of this triangle, and this area would be A2. And you can see if I subtract A2 from A1, so A1 minus A2, it will give me my required shaded region A. That's what we need to do. So there are two steps I'm doing here. First, I'm going to find area between 1 to 4 after integrating an A, and then I will figure out the area of the triangle. So let's start. First, this is the point 4, and I'm going to integrate from 1 to 4 y dx, and y is this equation. So 3 by 4 x square minus 4 root x plus 7 dx. And if you integrate this, you would have 1 upon 4 x cube minus 8 by 3 x to the power 1.5 plus 7x. And we don't write c because we have a definite integral. Instead of c, we write limit 1 to 4. And the next step is applying limit. First, we need to apply 4 in place of every x. This is called upper limit. Applying upper limit, and then minus, and then I'm going to apply lower limit in every place of x. Lower limit. That means my area A1 would be equal to 1 upon 4 cube, this is the product, minus 8 by 3 4 to the power 1.5 plus 7 times of 4, this is upper limit, minus lower limit. And because I have minus, so don't forget to put the bracket. So lower limit is 1 upon 4 1 to the power cube, this is cube, minus 8 by 3 1 to the power 1.5 plus 7 times of 1. If you simplify this, your area would be equal to 18.08. This is the area. The whole area included shaded and unshaded region, A1. Now it's time to figure out the area of this triangle. That means A2. So area A2 is this much, and because we are talking about only unshaded region, and this is triangle. For area of the triangle A2, we are going to use the normal method. That means half of base into height. So we don't need to worry about height. It is because the height is 11. Why 11? Because 11 is the y coordinate of point P, and y coordinate is generally gives us the vertical position or vertical height. So height is 11. The only thing we need the base. This is the base that we don't have. So we need to find this base. And we know that from the x coordinate of point P, which is 4, this distance, the total distance is 4. This is 4 unit. If we can figure out coordinate of this point, which is the x-intercept of the line, that means we would have this much, and we can subtract this from 4, so we can have the base. And how do you find this x-intercept? Remember, this is x-intercept of the line. That means you put y equal to 0, so x is equal to 9 by 5. This is horizontal distance, 9 by 5. So A2 would be equal to half of base, and base is 4 minus 9 by 5 times height. Height is 11. So A2 is 12.1. So finally, the area of shaded region A is A1 minus A2, meaning 18.08 minus 12.1. So A is equal to 5.98. This is the area of the shaded region. Thank you very much for this video. Have a nice time.